Sorry, it's loading. Awesome. Okay, it seems like everything's ready. Hello and welcome to day 5 of the QC Hack Bootcamp. We're happy today to be collaborating with qBraid and the Duality Quantum Startup Accelerator to bring you a series of presentations from the founders of several quantum startups. Founding and managing a startup requires a really diverse set of skills, and Duality's partners will talk to us today about how exciting the experience can be and further illustrate the diverse approaches that can bring one to the field of quantum computing. And now it's my pleasure to introduce Chuck Valurupalli, a seasoned business executive and engineer. He sets their strategic vision for Duality, oversees program operations, and cultivates a relationship with key partners. Now it's, without further ado, let me hand the floor over to Chuck.
Hi, Ben, thank you. What an amazing event. I was looking at some of the sessions and how all of you came together to create this. Just amazing. And this is exactly what we need for innovation, and especially innovation in this case in the quantum space. So Duality helps early stage quantum startups to accelerate and succeed. As you all know, going from an idea to actually creating a startup and then taking the solutions offered by the startup to be valuable for the customers is a long journey. It's a crawl, walk, run approach, right? So what Duality does is bring together highly curated resources, expertise, and the networks needed for the startups to succeed. So we are able to introduce our startups to prospective customers, prospective investors, prospective talent, but more importantly, not just introducing them to these resources and networks, but also preparing them. So when they meet their customer, what should they do, right? What questions should they ask? What is the right way to discover what the customers need? And then when it comes to investors, what is it that the investors are looking for, and how do you go about selling your story? So these are the kinds of things we do, accelerators do, and especially Duality. We are hyper focused on highly specialized expertise and resources relevant to quantum startups, right? So what are the expected outcomes? So you have all these things that an accelerator provides, and then people like you come up with an idea or an early stage startup, and then we provide all these resources, networks, expertise. What's the outcome? So at the end of the program, when you participate in Duality, an accelerator like Duality, you will most likely end up with having a better business model. And the business model includes broadly 3 things. Finding a large market that has a desire for the solutions that you're creating, and improving the feasibility of creating the products and the solutions. And also finally making the company more viable, and so that it sustains for a long period, helping out its stakeholders. So those are essentially the kind of outcomes: better business model, adoption by the customers, helping startups find early customers, and then last but not least, finding some amazing talent like many of you here, right? And because that is really one of the backbones of a startup, the team, the talent. So with that, what I would love to do is open up the floor for the startups, but I would like to make a few suggestions on observing a certain some things when you look at hear about these startups. So when you hear about all these startups, you will observe that there are different types of startups, not just quantum computing, but there are startups that are doing other things. There are hardware startups, software startups. Some of these startups are catering to a certain type of industry. So I would encourage you to, as you hear these presentations, really understand what is unique about this startup. This is what I would encourage you to think about as you listen to this. What is unique about these startups? Why would customers, or why are customers buying their products? who are these customers? What do these people do in their day-to-day jobs? What jobs are they trying to get done, which makes the solutions provided by these startups valuable? And then also take a look at how have they grown? What has their journey been? What do the profiles of the founders look like? What does the composition of the team look like? Is it a combination of technical and business people? So I would like you to pay attention to those kinds of things, so that when you have an idea, hopefully one of these days, or perhaps you already have an idea, you can also start thinking about your idea, and then formulating a plan on communicating your story in a nice way, so that your prospective customers, your investors, or a prospective new hires, they all value and are excited about what you're doing, right? So again, I think the startups will tell the story in a nice way, and you will get some hands-on experience as you listen to them. So Ben, with that, without any further ado, I would like to pass it on to, I guess, Kana, next presenter.
Yes. Thank you for sharing that. Great words about sharing your story. And yes, with that, we can pass the floor over to Kanaf to talk about qBraid.
Yeah. Hey, it's so exciting to be doing this panel. Thank you so much for organizing it. And yeah, the story of qBraid, I think one of the main things we wanted to do for all the researchers or people getting into the field of quantum was easiest access to the quantum software as well as hardware. Our goal is to provide you the entire ecosystem at your fingertips. In the next 3 to 5 years, a few main questions in the field of quantum computing will be: which quantum computer is the best? What application is going to be the first one to be addressed by quantum computing? And how can you get access to these machines easily? And so essentially, our focus has been to provide you a ready-to-go platform all in one, where you can just log in with your email and password and get access to all these software and hardware in a single place. So I'm gonna share my screen briefly to give you an overview of what we do. So this is our main website, the entire quantum ecosystem all in one place. So what we do is when you log in, first it's super simple, just an email and password. And when you log in, you'll see 2 sub-platforms. One is the Learn platform. The second one is Lab. Learn, as the name suggests, is focused on just learning quantum computing. So let's say you don't have any background. We've got 1 course already published. We will be rolling out many more new courses in the coming months and the rest of the year. And the best part about this platform is when you go to this course, you will see that not only you have easiest access to many of the HTML, the text and then interactive widgets, but at the same time, you can also easily run the code snippets as well. So essentially, if you don't have any background in quantum computing, we take you from not knowing anything to running your first quantum program in under 2 minutes. Once you've learned quantum computing, you can move on to our next platform called lab.qbraid.com, which is built for people to build software. And this provides you access to all the different SDKs as well as quantum hardware in a single place. Our goal is to provide you the access to not only these quantum software, but the cutting edge research as well. So our benchmark is, let's say a new study comes out with the most cutting edge application. We want to provide you a platform where you can replicate all of that in under an hour or 2. And as you can see, you'll have many of the different SDKs available and ready to go, and you'll be able to run on quantum hardware. And that essentially is the goal for qBraid. As we develop further, you'll see many more application-focused quantum software popping up as well, with which you'll be able to develop and then deploy. So our goal is to enable you to learn, develop, and then ultimately deploy. Yeah, that's pretty much it.
Wow, thank you so much. All right, now I'd like to hand it over to Mirela Kuleva to talk about Quantopticon.
Thank you very much, Ben. I'm very pleased to be here today. So thank you for the invitation. So Quantopticon is a software startup, and we are building a rapid design and optimization platform for quantum photonic components, subsystems, and integrated circuits. And the purpose of our software, which is called Quantopticon actually, is to accelerate the development of high quality quantum photonic components, the development of high quality and scalable quantum photonic technologies, so that we can speed up the advent of this amazing quantum 2.0 revolution that is coming. So with Quantopticon, we actually eliminate the need to perform expensive and time-consuming trial and error experiments to make these devices, and instead we replace the experiments with relatively quick and precise simulations. So what we do essentially is we model the quantum dynamics of light-matter interactions in photonic nanostructures. And at this point, I would like to introduce my colleague, Gabi Slavcheva, who is Quantopticon's Chief Scientific Officer, and she will show you a demo of Quantopticon. Gabi, take it away.
Yes, thank you, Mirela. Well, I'll give you a flavor of our software and our capabilities. Basically, we are describing a discrete energy level system. For example, it can be this system with transitions, optical transitions between the energy levels, or we can describe systems with up to 16 discrete levels. For example, we can describe a neutral exciton system, which is a 4-level system with all optical transitions, dipole optical transitions, which are allowed, described by these double-headed arrows. We then have to construct the photonic structure geometry, because the quantum system is embedded in a photonic structure geometry. In this case, for example, this is a micropure structure with DBR mirrors, bottom DBR mirror, cavity, lambda cavity. In the middle of the cavity, we have the quantum system and top DBR mirror. All these layers can be described by refractive indices, which are calculated within the program. Then we can describe the pulse sequence, optical pulse sequence, by which we are exciting the qubit, the quantum system. And for example, we can describe various pulse shapes like Gaussian pulse, hyperbolic secant pulse, or any other shape of pulse with different polarization as well. For example, for a Gaussian pulse, we can describe circular polarization, not just linear polarization. We can then set up the boundary conditions on the left and right boundary. There is a selection of boundary conditions for the left and right boundary separately. And finally, we can show the results, which we can visualize basically the dynamics of the pulse, which is an initial pulse, which is launched from some point along the structure. We can select the point from which the pulse is launched. And we can visualize the time dynamics of the initial pulse, the time dynamics of the emission out of the cavity. For example, this is the initial pulse. On the right-hand side panel, the emission of the cavity outside at the final panel. And we can also visualize the quantum dynamics, the population dynamics within the quantum system itself, as well as a snapshot of the population and field dynamics at a particular time moment. So basically, we are now working on developing an analysis menu, which will perform Fourier transform and compute various quantities of interest, such as statistics of irradiation and demonstrating, for example, anti-bunching and single photon generation, or other type of quantities which can be detected in experiments, such as, for example, time resolved photoluminescence. So we are looking for people that understand software visualization and software, manipulation, processing of large data sets. to join our company. Thank you.
Yes, and I'll add that I will put our contact details in the chat, and please feel free to reach out to us if you find what we do interesting. And we look forward to hearing from you. Thank you.
That's awesome. Thank you. All right. Well, thank you, Mira. And so now I would like to pass it to Keith Evans, who's here to talk to you about GLCT, the Great Lakes Crystal Technologies.
Okay. Thank you, Ben, very much. We'll just get this thing on here full screen. And I'll share. There we go. Screen 3. You guys can see that. Yeah, thank you so much for having me here today. It's a pleasure. I'm co-founder, president, and CEO of Great Lakes Crystal Technologies. Our mission is to become the leading provider of high-performance diamond materials for high technology applications. I just have a few slides here I wanted to share. Of course, you know, the meeting today is focused around quantum technologies, but we're one of the hardware companies that Chuck alluded to that there's many markets kind of calling out for what we are developing and will be providing. And so this slide here shows the 4 application spaces, and each one is quite broad, that has shown pent-up demand for high-performance diamond materials. And I've highlighted the ones that we're most focused on. It was through intense customer discovery, actually, in an NSF I-Core like program, I-Core Lite, that I strongly recommend all startups go through, that taught us about the quantum side, being so interested in the diamond materials. For decades, engineers have known that diamond made great sense for electronics. It's called the ultimate semiconductor, but it's also very difficult to make. And so one has to get big, nice form factor, inexpensive diamond wafers before it's going to be as prevalent in electronics as, say, silicon technology. But that very well could happen, because we're feeling great pull from 5G and 6G base station applications. And then there's these niche high margin markets that need diamond for X-ray optics in the beam lines and for detecting X-rays and many, many other things, with a lot of upside potential in the medical application fields. So we're in 2022 here. We started the company in August 2019 and have been operating mostly fabulously. We've got a ton of SBIRs and STTRs showing that the federal government has huge interest in these materials and what they can enable. And so I'll show you a summary of some of those contracts we have going. But we are building a pilot line as we speak in East Lansing, Michigan, just off campus at Michigan State University, where our technical founder is a full-time professor. That's Professor Tim Grotjohn. And we've been able to leverage state and local support to get ISO 9001 2015 certified even before we enter the market. I strongly encourage any startup to get an ISO certification as soon as possible, because it's not that the certificate doesn't help you at all. It's the discipline that you need to learn about in order to get that certificate and then maintain it going forward. Currently, we're just about done building this pilot line. We closed on our first $1 million in seed financing, and the equipment's coming in as we speak in East Lansing. And then right now, the executive team is working really hard to try to put in a kind of a $10 million facility. And I think it's most likely to go into the Chicago area, in large part because of the wonderful things that we've been exposed to by being part of the Duality Quantum Accelerator program that Chuck runs and Preeti helps with. So we hope to build a mini factory and applications lab. This may be on University of Chicago campus. We're not sure. We're having these conversations. It may have a very close relationship with Argonne National Laboratories. We're hoping that it does. And then long term, we want to get into, build a domestic high performance diamond manufacturing center. And it's possible the center here will be the first step in the same facility. Still trying to figure out what that looks like. So tons of SBIRs and STTRs. And if the early adopters are in the Department of Energy side or Department of Defense, as they often are for cutting edge technologies, I behoove you to look at the funding possibilities. You can see the numbers there. I think I'm getting close to my 5 minutes. So the team is the most important thing, and I've lost all my hair, but it's important to have, it's great if everybody's young in the startup, but I behoove you to reach out and find seasoned veterans to help you grow the company. The Duality program exposed us to Moose Chagall, who has joined as our executive chair. The special ops has if you want to reach out to me, I'll be happy to share these slides to you. That's hyperlinked to several University of Chicago students are helping us in their spare time. And then we have a fantastic team with tons of experience on the diamond manufacturing side and the go-to-market side. And then great people expose you to other great people. So we have Mike Froy is our lead counsel and he's global chair of corporate practice at Denton's, the world's largest law firm. And I won't belabor these people, but I think, yeah, I was building a thank you slide and I didn't get there. But thank you, and I'll put my contact information in the chat as well. Look forward to the Q&A.
Thank you so much, Keith. We really appreciated that great look at Great Lakes Crystal Technologies. All right, now I would like to hand it over to Pranav Gokhale to talk about SuperTech.
Hey, thanks for having me. So first off, just want to thank you, Ben, and thank you, Ricky and qBraid and Knav for organizing this, as well as endorsing Duality as a program and all of my fellow startups. I think they're all doing really great stuff. So just to tell you a little bit about SuperTech, we're a spin out of research from UChicago and launched about 1.5 years ago. And our mission is to accelerate quantum computing. At a high level, our core thesis is that the software stack for quantum computing is broken. Right now, it's composed of dozens of layers in the stack. And what I developed during my PhD was a technology that we now call SuperStack, which basically takes a shortcut from end user applications of quantum down to the actual pulse level analog controls that operate quantum hardware. And our belief is that this technology is going to essentially enable quantum to happen 5 years sooner than otherwise possible, basically using software as a force multiplier for the underlying hardware. And in terms of where we are in terms of getting to product, we made a few key design features. The first is that SuperStack is write once, target all, meaning that we interface with open source quantum languages like Cirq and Qiskit, where we have clients on GitHub, as well as outputting to any quantum hardware out there, with more coming quite soon. The other piece that is important is we've designed the stack to be very application centric. We're in use by finance companies and energy professionals who don't know Schrodinger's wave equation, but want to get exploration of quantum speedups. So we launched this in beta around 8 months ago, preparing for a full launch later. And the beta launch has an open API with early adopters, including big companies like Morningstar, as well as national labs like Argonne and Berkeley. And one of our key customers is Berkeley Lab, which uses our software. They own the federally funded Advanced Quantum Testbed, and they use their software to optimize the execution of programs on their hardware. Another thing that we launched is SuperMark, which you may have seen in the news. It's our quantum benchmarking platform. We just found out that the paper for it won the best paper award out of 280 submissions at HPCA. So that was kind of exciting this week. Stay tuned for some coverage about that. And a little bit about the company history. We've raised over $3 million in government grants and early revenue. That includes most recently a $1.7 million phase 2 grant from the Department of Energy. And we're working on building customer contracts for proof of concepts. This is the team. I co-founded it with Professor Fred Chong at UChicago, who is actually my PhD advisor previously. And we have a team of 14. Half of our team has PhD training in quantum computing, and we're hiring and growing rapidly. I have a couple minutes left, I think, so I was going to speed through these slides, which I did, and then change to sharing examples of what SuperStack is. So hopefully you can see the screen here. This is an example of our open API, or it is our open API. And basically we have all these different get and post endpoints where you can do things all over the stack. Some of them are at the top of the stack, things like solving portfolio optimization problems, max Sharpe ratios using quantum solvers. Other ones are closer to hardware, for example, interacting with pulse and variable configurations for the advanced quantum testbed and compiling to it. These are some of our example notebooks, and they're all open source. The advanced quantum testbed at Berkeley uses this kind of framework to use our compiler, and they get back pulses that actually execute single qubit gates as well as multi-qubit gates on their underlying hardware. We do the same thing for IBM, where we've set the world record for having the best swap gate on IBM. And then on the application side, we have a customer now in the finance industry, a major national bank, who's using our software to solve portfolio diversification problems and basically enact this write once, target all feature where they talk to IBM, IonQ, and other providers at the same time. And then the last tabs I'll put up are Supermark, our interactive results for quantum performance, includes this nice visual essay, if you will. And we have a lot of different partnerships with BCG, Amazon Web Services, and Protiviti about getting the word out. And I'll put these links in the chat. So I think I'm about at time, but thanks for having me here, and feel free to reach out. I'll put my email address in the chat as well.
Yeah, wonderful. Thanks so much for being here and talking with us. Now I'd like to hand it over to Paris Sissel to talk about QuantCAD. Thank you, Paris.
Hi, everyone. Just going to share my screen really quick. So as Ben said, I'm Paris. I'm from QuantCAD. Unlike the rest of the people that you're hearing from today, I am not a scientist. I do marketing. During my BBA, I also had an emphasis in entrepreneurial management, since I've known I wanted to work in the startup world for a very long time. So QuantCAD is a software company where we enable the growth of quantum technology through the creation and distribution of noise solutions in a fair and equitable manner. Our motto is information, not noise. So we all probably know that quantum noise causes information to be lost. In sensors, this causes unusable readings, but I know you guys are interested in computing. So noise causes a decrease in the depth of an algorithm in quantum computers. So here you can see this big noise barrier that's keeping us from taking these technologies and turning them into higher markets and better technologies. So our innovative software simulates quantum noise. And once you cope with noise, it allows devices to operate at higher temperatures and produces accurate real-world device simulations. This leads to a reduction in equipment and operating cost while also simplifying the technology, and leads to faster device improvement cycles and eliminates the trial and error design process while giving you confidence in an optimal design. So here's a bunch of things that our software can do, but the thing I want to point out is that we take our software and we customize it to what our customers' needs. So our noise software and services have been purchased and successfully applied to improve device performance by national laboratory, university, and industrial users. Here's our development roadmap. So here we are right now focusing on sensors and magnetometers. That's mostly due to where our software is in its own development, but eventually we want to get into these transducers and quantum computing, because as you saw, noise is an issue across the board with quantum technology. So again, we do information, not noise. We do microscopic simulation and emitter line width and surface-induced noise to lead to successful quantum device design, simplified technology, lower operating costs, and faster device improvement cycles. Our team is made up of Michael Flate, our chief scientist. He is a leading quantum physicist with over 2 decades of success in simulating quantum coherent materials and devices. Our software was mostly developed in his research group at the University of Iowa. Jigang Niu is our technical officer. He is an expert in modeling complex quantum mechanical materials, including inorganic, organic, and organic inorganic semiconductors, low-dimensional nanostructures, and metamaterials. Jennifer Flate is our CEO, and she has a lot of experience in organizational management. And then we have myself. I call myself the marketing wizard, because why work for a startup and do marketing if you can't have a little fun? But together, the four of us really make a great team. Startups are crazy, as you probably know, and teamwork is a huge factor in that. So I'm really thankful that our team can communicate well and just get things done across the board. Thank you.
Thank you so much, Paris. All right, next, I'd like to pass it to Carol Scarlett to talk to you about Axion Technologies.
Hi, everyone. Thank you so much. Thanks for having me. Let me share my screen and give me just a second. Let me put this in the right mode. So hi, everyone. I am Dr. Carol Scarlett. I'm an experimental nuclear and particle physicist, and my startup company is Axion Technologies, LLC. We are a hardware company, and our work is in the area of quantum random number generation. So you just heard about the need to get rid of noise. Well, my company focuses on using noise for a whole host of computing applications. So just to tell you a little bit about my company, it may surprise some folks to know that at the core of much of 21st century computing architecture, everything from data simulations to artificial intelligence, and the biggest one of all, of course, is computer encryption, requires randomness. So we have a process and mechanism for generating truly random numbers. This is using quantum mechanics, which is the only true source of randomness. And so my company was founded to develop hardware devices and to provide random numbers for a host of computing applications, but more importantly, to keep data secure. Okay. And we advertise that we can do it better, cheaper, faster. We have focused unique patented technology on developing some of the highest speeds of quantum random number generators, and we can do it at a reduced cost compared to our competitors. And the reason for this is that we have a uniquely designed system. We have designed for high performance computers. And in doing so, we've been able to come up with a number of verticals. Our technology is sort of based on using optics and manipulating the quantum properties of polarization to make our randomness. Mm-hmm. And right now we hold 3 patents, 3 issued patents, and we have, actually I should update it, we have about 4 patents that are pending for this technology. The technology itself is designed initially around going into high performance computers. This is where you have just really high throughput and bandwidth. High performance computers are right now used ubiquitously in national laboratories and in a lot of universities. Eventually, we would like to be able to serve artificial intelligence. And finally, the biggest market, of course, is for encrypting and securing data. And I think not a day goes by that you don't hear about data breaches and hear about stolen passwords and stolen information. And in the coming era of quantum computing, as you've heard from 2 of my colleagues at Duality who do quantum computing, the biggest fear is that even if you've encrypted the data with enough computing power, someone may one day be able to decrypt it. So you really want to be in this space of being able to use very secure passwords, very large scale one-time pads. And this is something that Axion Technologies has a unique infrastructure that can build. You can see here that we do, of course, like all companies, we have competitors. There are other people who've looked at similar problems. Most of your larger companies are doing pseudo-random. There are a few companies that do quantum random number generation. They still tend to be slower. And what we've done is something very unique. We use optics, so we tend to have speed, but we also read it out in a way that we develop parallelism. Again, that gives us a competitive advantage. More recently, I myself have been working under chain reactions innovations at Argonne National Laboratory to take our devices and scale them into a chip. And then as a chip scale device, we could go ubiquitously into all kinds of computing infrastructure, everything from your autonomous vehicles with 80 to 120 CPUs down to your standard laptop with just a couple of CPUs and your cell phones and such. And as a company, of course, we are in the fundraising stage. We got our start with a Small Business Innovative Research Grant through the National Science Foundation. We've continued to work using grants and using non-dilutive funding. We are looking to do a fundraise soon. We also, I should announce, have received some support from Luminate. So we will be partnering up with Luminate and looking at developing quantum randomness and the infrastructure for it. By the way, randomness is slated to be about a $7 billion industry in the next 4 to 5 years. And in addition to our quantum randomness, we have some unique optical products that will enable network communications. So the company has multiple directions that we can go into. And finally, I'll just say a little bit about my team. There's myself. I'm an experimental nuclear and particle physicist. I'm joined by 2 research assistants who are very skilled in making and testing and using optical devices. And I recently hired a sales manager who's had over 15 years experience in sales. And so we are Axion Technologies, keep the future random. And if you have any questions or want any information, my email address is here. And I look forward to hearing from you. Thank you.
Thank you very much, Carol, for that wonderful presentation. So at this point, I'd love to pass you. We had a question here in the chat. So somebody asks, and this is an open question to anybody who'd like to answer this. How do you anticipate quantum algorithms and quantum computing to change our approach to cybersecurity and risk assurance? Yes, Carol, absolutely. Feel free to turn your videos on at this point.
Okay, thank you. So I'll just jump in and start this, although I'm sure that both Pranav and Karnav can probably address this more effectively from the computing side. But I do know that having looked into some of these issues, I do know that with computers that can very rapidly generate new, potentially new passwords, it'll reduce the amount of time that it would take to hack or crack some of these standard ways that we do encryption now. So there are some folks that have suggested that we would go to a different form of encrypting data where you basically would look at sending communications and collapsing the state so someone couldn't do a man-in-the-middle attack. But for sure, a lot of our old data may be vulnerable to potential thieves because of quantum computing. So in the very near future, we expect quantum computing to have a huge impact on how we will go forward with encrypting. There are some approaches to getting around just being able to brute force, come up with all the combinations for a 2 to the n. But I guess I will let my other colleagues who do computing algorithms and might know a little more about that speak on it.
Yeah, sure. I can add to that. So it's a really good question. And I think Carol touched on some of the important points, which is that quantum computing will be a threat to encryption methods, security methods. And I think solutions like the one Carol is building actually will be relevant to ensuring, for example, if you have safe random numbers, that helps you a lot. Quantum key distribution is another area that is promising. Another point was risk detection, I think, or risk evaluation. And I actually maybe would point to this as a potential overhyped area of quantum. And the reason is that it is known that there are quadratic Grover type speedups for a lot of problems such as Monte Carlo simulations or search more generically. But it is also believed that quadratic speedups are not enough to have a practical bearing on real world situations. And the reason is that, yes, it might take order root t time to solve a problem with quantum computer where it would take order t time to solve it with classical computer, but that hides constant factors. And the costs of quantum error correction are in the order of magnitude of 10⁻⁹. So it generally erases those advantages. However, there are problems in the risk industry, such as finding the least correlated amongst potentially risky assets. That's not a Monte Carlo problem. It's more of an optimization problem. There you could have substantial quantum advantages. So it really depends on the problem. The cybersecurity one, as Carol pointed out, that's a place where you have a true crisis in ways when you have a real quantum computer, because that's one of the exponential advantages.
Yeah, awesome. So unless, I mean, if anybody else would like to answer this question, definitely. I also have some questions of my own after hearing these awesome presentations. So if you don't mind, I can transition to some of those. So for I had a question. So what led you to found qBraid? Obviously this, there's a very big ecosystem around like these like cloud computing tools that, at what point did you have your idea and think, oh, I want to make this into my own startup, my own company?
Yeah, that's a great question. I think when I was very close to graduating, that's when I think Zapata came out with a big announcement of their seed and maybe Series A round. And one of my really good friends, Peter Johnson, who I shared office for a couple of years, he was one of the co-founders. And I think that was like a defining moment. For one, it seemed like, hey, someone very close to me did a startup. And the second thing was there seemed to be a decent appetite in the VC world to start investing in quantum startups. And it seemed like this might be a time similar to the internet boom where things were just starting to take off. And at that point, I realized that I didn't just want to go and work for somebody else and maybe found my own startup and build something that we can be really proud of. Yeah, and that's the story where I just didn't want to be a player in somebody else's movie.
Wow, thank you. Compelling reason, definitely. So we did have another question appear in the chat. I thought this was a really good one and I wanted to open it to all of you. Someone asks, can you please tell us how do we make a startup in quantum computing and what are some of the first steps we should take?
Oh, I can just broach that. So if you're going to make a startup in quantum computing, and I think some of my colleagues can also talk about this as well, I would say one of the first steps you should take is after you get incorporated in whatever state you're going to incorporate in, make sure you go and register for SAMs and register for a DUNS number, and then go and look at the Small Business Innovative Research Grants, because your first funding will probably come from federal funds that are set aside to build companies. And these are non-dilutive funding. The grants you do not pay back, but you have to have a really good project and you have to convince people that there's going to be a market for it. But your first steps, it will probably take you about a month to get your SAM's number, DUNS number. And then after you've gotten those, which are just really practical steps that you have to take, you want to go through Small Business Administration, look at all the SBIRs that are available, determine which one is tailored to the type of project that you want to do. Of course, you have to come up with a good project that you want to do. But that would be the first steps, is look for that non-dilutive funding.
And I think, so those are great, great reasons. And one of the few things I want to add is you want to be very clear about the idea. This is what I think is very, very important for quantum startup, and something that Pranav mentioned briefly. There are very few algorithms which provide you speed up, and even in those, it's not very clear if the speed up will persist when you take into account the overheads, right? So this is where I would say you need to be in the field for at least a couple of years to know the field and know whether there's going to be an advantage or not. Quantum computers are not like GPUs or new kinds of really fast processors, but it's a fundamentally different technology. And so I think that the technological idea needs to be very clear.
I can answer this question from a non-science perspective. For any startup that you have an idea for, you need to make sure that there's a pain point that you're solving, or a different approach to the pain point that you're going to solve. So you either need to be able to compete on price or quality or on scarcity. And if you can't compete on any of those three fronts, then you should rework your idea.
Great. Lovely. Thank you, guys. We have a follow-up question about attracting investments. So yeah, is there anything like you guys like to say about that?
Maybe one point tactically is a lot of us here have raised money via something called SAFE, stands for Simple Agreement for Future Equity. In fact, I think the majority of us here have raised some sort of SAFEs. And I think that's a really good path to raising money at the initial stage. Basically, it means investors give you money, yay, but it's too early to establish a valuation. And so essentially the investors just, when you do raise a price round, if you raise a price round, like a Series C or Series A, that's when the previous investor money converts into investment. And they get, because they came in so early, some 20%, 30% advantage, basically a return, but then they just convert to stock in the Series A, Series C. So I think that's a pretty good model for an industry like quantum, where, I mean, I think none of us are like having tens of millions of revenue right now. That's certainly the goal one day, but investors are too nervous to put a price, and we probably are as well. And so that's a pretty standard path for, I think, quantum startups that get started. Maybe a second piece just to mention is, in retrospect, one learning is I wish I had spent less time trying to solicit investors and more time trying to solicit customers, because ultimately the customers matter more. And if you get customers, the investors will come by the droves. So customers over investors.
I would also add that you should really try and make an effort to understand the terms of the negotiation terms with the investors before you commit to an investment from them, just to understand how it will affect you in the future. And you'll need to make some compromises to make sure that they're happy and that you're happy as well. And this is a good point for you to get in touch with a lawyer to get some legal counsel on this. They can explain the terms to you. They can guide you through the process. And if they have a lot of experience, they will know what kind of snags can come up in the process. And also they can advise you about which way to negotiate, that is going to be the best for the company in the long term.
Yeah, lovely. Those are great insights. Thank you, guys. I'm wondering if someone from GLCT is available for a question. Great. Yeah, we have a question from the chat saying, have you tried to use the diamond material that you mentioned during your talk for quantum computers? If you did, he wonders if super cold condition will be needed for that purpose in your hand.
Super cold?
Yes.
Condition? Yeah, it's a great question that I can't answer. One of the benefits of diamond is that it has some really interesting color centers that behave reasonably well. In one case, the nitrogen vacancy center has really great long electron spin coherence times at room temperature. So I think the vision of diamond in quantum technology applications does not involve cooling it. And so my hope is someday that you'll have a cell phone with a diamond-enabled quantum computer inside of it. There's others that know a lot more about the application side that believe that as well. But one thing I've discerned from all these great teams and so many other people that I've met on this journey is that there's a lot of competing approaches on the hardware side in quantum computing. So I think we're very bullish that, and Michael Flatte has helped me understand this, I'm very bullish that diamond quantum materials will have a play in quantum sensor technology. I'm not sure where they show up in 10 years from now in the quantum computing side. But there's great business opportunity for us either way, so we're okay with that.
Yeah, thank you, Keith.
Sure.
One more question going back to quantum computing startups, and I'm going to tweak this question a little bit. in the current landscape of QC startups, what's easier entry point? Software-based problems or hardware-based problems? Yeah, it's an open question for anyone to jump in.
I mean, while I have the floor, I'll say a little more. I mean, the wonderful thing about advanced semiconductor materials is they have all kinds of applications. So my feeling is it's easier for us. The quantum technology field does not have to mature for us to do well. But I see my colleagues more on the software side making some really interesting moves and getting traction now where I think others would have said they wouldn't have, and they are. And so it's exciting there, but enough said.
All right, so yeah, I'm sorry to have to cut us off, but I think we should end a minute early so that our viewers have a second to get up and stretch before our next event, the Journeys in QC Roundtable, which will start at 1 p.m. Eastern. So I'd like to thank you all so much for being here. And I know, as you work at startups, you all are very busy, and so we're very grateful for your time. And we'd especially like to thank the Duality Quantum Startup Accelerator for the amazing work they're doing in helping these innovative startups survive and thrive in the current quantum computing ecosystem. And we'd also like to thank qBraid for their help in organizing this event. And lastly, thanks to our audience for tuning in, and we hope to join you virtually for the Journeys in QC panel starting in a few minutes. Thank you.